class, we are going to be talking about Chapter 15, Lesson 2, which is rectangular solids, which is why I have a almost rectangular solid here. It's just missing one side. So rectangular solid is like a box, okay? Each of the sides of a rectangular solid is, as you may guess by the name, a rectangle, okay? Rectangle, different size rectangle, the rectangle, rectangle, rectangles form all the sides on a rectangular solid. So a rectangular solid is a polyhedron that has 6 rectangular faces. Okay, so we have intersecting faces lie in perpendicular planes, opposite faces lie in parallel planes. So this face and this face are opposite each other, so they lie in parallel planes. Yep. Okay, cool. What we want to talk about mostly is calculating diagonals. This is the thing with rectangular solids that I see come up the most on standardized tests. It is also vaguely practical for if you are, say, buying a box to pack something in that is of unusual size and shape. Let's say this pasta strainer. Bear with me, we're in quarantine. I have limited access to supplies. So let's say I had this pasta strainer, or you can imagine it to be something more exciting, and I need to pack it in a box to send it to someone. And it's too long, okay? It's also still too long to go this way. I can't go diagonally across the top. I can't go lengthwise. But again, I'm stuck in quarantine. I only have so many boxes. So I'm trying to work with what I've got. What I can actually do is maybe tuck it in this way. Okay, so that it's now at this kind of elevated diagonal, as we can see there. So this is the diagonal that they're talking about in lesson 2. And it's hard to see in pictures, so they do draw a picture of it here. And so X, that blue line, is the diagonal that they're talking about. And it's the diagonal that this slotted spoon is on. So it's going from the top corner here of the box down to the bottom corner on the opposite side. Okay, so top corner, so we're at the top of this right corner to the bottom of that opposite left corner. That's the diagonal that we're talking about. Okay, so let's say you're trying to find a box or order a box or buy a box to fit whatever unusual piece you're trying to send, like the serving spoon. This is not a dimension that they usually give you on the packages, but it is easily found if you know the standard given dimensions, like the height, the length, and the width. So we're going to talk about this side here as being the length of the box. We'll talk about this side here as being the width, and then the height is, of course, how tall it is here. Okay, so that's going to be our height. Okay, and I can actually draw that in here. So when I'm talking about the height of the box, that's going to be that corner back there. That's our height. Okay, and then our length will be right along here, and then our width. Right along there. Okay, so those are our standard dimensions that were given for boxes like this. But again, we're trying to find a different length. We're trying to find a diagonal that's not this diagonal, which we will calculate because we need that, but not this diagonal that's just a diagonal across that rectangular face on the bottom, but actually then the elevated diagonal. So going from the top corner down to the bottom corner. Okay? So, but like I said, we do need this diagonal as well. Okay, so we're going to use all these pieces in order to solve for this kind of invisible diagonal. Okay, why? Because of course we're going to use the Pythagorean theorem and right triangles. And that how we solve everything around here. If I need to find this, I want to think of that as the hypotenuse of a right triangle. Okay, so there's going to be the top of it. The hypotenuse is going to go down to this point over here. So it's going to be the hypotenuse of a right triangle. This diagonal here, okay, that we can see that we've drawn along that rectangular face there, that diagonal is actually going to be the bottom leg of that right triangle, okay? And then the height, whether you think of it back here, or it's going to be the same over here, the height will be the other leg of that right triangle, okay? So you've got a leg of the right triangle here, you've got a leg of the right triangle there, and then your hypotenuse is coming down here from this top corner there, top corner, okay, down to this bottom corner over there. There's your hypotenuse. Okay, so we have to do two different calculations in order to get this. Because first I need to find out how long this is. And that's pretty easy because it's a nice right triangle. We know that this side, we've got the width here, okay? And then we've got our length running here. And so with the width and length, those become two sides of the right triangle. And so I can calculate this as the hypotenuse of this right triangle. So you do that with Pythagorean theorem. That gives you this length. And then this length and the height then become the legs of the other right triangle. Okay? So it's just a combination of those two right triangles. And if you do that, that will give you that unseen diagonal. Okay? So right triangle with length and width as the legs. And then another right triangle with that diagonal and the height as the legs. And that gives you the missing invisible diagonal there. Okay? Good luck with lesson 2.